All right, we're going to get started. People are going to still be coming into the room as we're doing this. It's being recorded. Welcome, everybody. I'm Paul Ferraro from Johns Hopkins University. I'll be doing the introduction. Today, I'm co-hosting with Johanna Eklund from University of Helsinki. We'll be moderating the Q&A, and Sebastian Costa-Doat from Conservation International is going to be talking at the end about a new mentoring program that's coming through the Impact Evaluation Working Group at the Society for Conservation Biology. So as you know, these seminars or these webinars are the first Tuesday of every month. At this time, we're going to be continuing through next year, so stay tuned for information about that. Just to remind you, we've got Erin Sills today, which I'm going to do the introduction, and then we've got two more for the rest of the year. Sabrina Eisenberth is going to be talking about harmonized implementation of experiments, multi-country harmonized field experiments for conservation evidence. And then we're going to be having a panel in early December with the members to be announced. So just some housekeeping details. We're going to start with the talk, about 30 minutes, followed by a moderated Q&A session. You can post questions in the chat for the moderated Q&A session, starting right off the beginning. You don't have to wait till the end. That'll actually make it easier for you on if you could put in some of your questions before we get to the end. If you find it helpful, you can activate the live transcription function in Zoom under the ribbon for more and choosing live transcript. But please note that the seminar is recorded, and the recording of today's will be later available on Society for Conservation Biology's Vimeo channel, which you can get there. We'll also be tweeting it out, and when the video is ready, we'll be sending a reminder to all registrants. If you've missed any of the previous talks, you can get them at the same location. If you want to engage with us on social media, use the hashtag Tuesdays with Team Counterfactual for the seminar and tag at IDoImpact. And so for those of you who have not been here before, the aim of this working group, the Impact Evaluation Working Group at SCB, is to advance evidence-based biodiversity conservation efforts across the globe by supporting the adoption of counterfactual approaches to understanding the impacts of conservation actions and interventions. So lots of ways that you can get involved, and we encourage you to do so. It's a growing working group. You can follow them on Twitter, sign up for the email list where you get information about this webinar series, as well as other activities that are going on, including sessions at conferences and other opportunities for funding. And we'll also be talking about this mentoring program for junior researchers at the end. Today, we are lucky to have Professor Erin Sills from North Carolina State University in the United States. I was just talking earlier with Erin that we've known each other for quite a few decades. We were actually shared in office many, many years ago when I was a master's student and she was a PhD student. And Erin did one of the earliest matching studies in conservation, looking at the impacts of the Payments for Ecosystem Service program in Costa Rica, looking about the social impacts and the environmental impacts with work with her former student, Rodrigo Arriagada. It's excellent work if you haven't seen it before. It's not only one of the first examples of matching in conservation, but it's also one of the first examples of partial identification. If you've never seen that method, take a look at the land economics paper by Rodrigo Arriagada and Erin, where they use weak assumptions to try to bound the effect in a way that policymakers will still find relevant information about the impacts of their program. So we're going to let Erin go for half an hour, and please feel free to ask questions throughout. I think I'm going to let Erin take over from here, share her screen.
Okay. Let me get to screen sharing here. Okay, can everyone see the screen?
Not full screen, but we can see the screen. There we go.
Now full screen.
Yep.
Okay, excellent. Well, thank you for the introduction, Paul, and thanks to all the organizers of this seminar series, which I really enjoyed. I think today maybe marks a little bit of a shift from more conceptual topics to focus on specific methods. And so I'm going to talk about the synthetic control method today giving you a high-level overview, but I'm going to do this by first recapping one of the original applications of the synthetic control method, not in the conservation field, but I think really helpful for thinking about how it does apply to conservation. Then I'll walk you through a couple examples from my own work of applications in the conservation field and wrap up with some more general reflections on the method. So that's the game plan. The seminal paper that I'd like to start with is by Alberto Abadi, who developed this method. And in one of his original applications, looked at the state of California. And so California, as I'm sure most of you know, is a real policy innovator in the US context. And so we want to learn from their policy innovations. But that lays out a challenge for Team Counterfactual because California is also pretty unique, right? That's why they're a policy innovator. Those are bundled together. And so it's hard to figure out who to compare California to because there just aren't many good comparisons out there. So Abadi recognized that one way to go about this is to draw on the good time series data on outcomes that we care about across various US states. And in particular, in this application, what he's interested in is the impact of policies on per capita cigarette consumption, measured as per capita cigarette sales in the different states. And the intervention that he's looking at is Prop 99, which increased the tax on cigarettes and directed those tax revenues to public health programs designed to decrease cigarette consumption. So that's what California did. And the question is, how much of an impact did that have on cigarette consumption or per capita cigarette sales? So we drew on that time series data and put together a weighted combination of other states in the US that hadn't had similar policies to reduce cigarette consumption and that had similar structural drivers of cigarette consumption. And as you can see here, nearly exactly the same historical trends in cigarette consumption. So this synthetic or weighted combination of other states is shown in the dotted line. It matches very closely to California's historical consumption of cigarettes. And therefore, that lets them in the period after Prop 99 look at what happened in that synthetic combination of states and treat that as the counterfactual, what would have happened in California if Prop 99 hadn't been put into place. So that's the essence of the method. You can look in his paper and there's tables there that show how the states are weighted, that show how they compare on these underlying structural factors. And he makes the case that that's one of the advantages of synthetic control is it's very transparent. You can see exactly what is going into that counterfactual. So in many ways, this is like matching with difference in difference. Again, except that you've got maybe more transparency. There's lots of discussion about differences and differences now, and Abadi would make the case that with synthetic control, you know exactly what's going on. The other difference is if you look at sort of the intersection of my two ovals here, you can see there's a pretty exact match. So the match is so good, you don't even need to difference, right? You have exactly the same cigarette consumption historically in the synthetic control and in California. So using time series data, transparency, the other key advantage of his approach is it's replicable. The choice of the states that go into that synthetic control is an entirely data-driven process based on a nested optimization that seeks to match those structural drivers of cigarette consumption and cigarette consumption itself. And because it's transparent, that lets you look at whether this difference that you see in the treatment period is significant. So using the synthetic control method, you could start with this graph and then look at these differences between the treated, the California in this case, and the synthetic control. Take those over and plot them in another graph. So here we have the dark black line showing the gap in cigarette consumption or sales between California and its synthetic control. And you can see that California after Prop 99 consistently falls further and further below consumption in the synthetic control, suggesting that Prop 99 was driving down cigarette consumption. But because this process of finding this gap was driven by a very systematic, data-driven procedure, you can apply that same procedure to every other state. And specifically all the other states that were in the donor pool or the potential control pool, and calculate a synthetic control for each of those states and calculate the gap for each of those states. And that's what's shown in the gray lines here. Of course, none of those other states had the policy. And so the gray lines are essentially showing us noise from the method, right? These are placebo effects from placebo tests. And so this lets us see that the California gap has real signal compared to all that noise, right? It's a way of figuring out how significant the effect is in California, even though we've just got that one state to look at. And that comes from the fact that it's a replicable data-driven process. It gives us this nice compelling graph. Both this one and the previous one, I think, tell a really nice story that helps explain what the impact is and make a case for that impact. So I will note that in the various applications of synthetic control that I've been involved in, I have rarely, if ever, gotten such a compelling graph, right? So a body has the perfect case here, and it really looks perfect, right? The synthetic control is consistently above California, starting right at that treatment period. This is a little bit rare in my experience to get something quite so clean. Maybe that's because in conservation, we've got so many different mechanisms and behavioral feedbacks going on. I more often find more heterogeneity in the impacts in the impact period, and not such a perfect match in the pre-treatment period. So that's the sort of the classic case. So let's think a little bit about what that means in terms of how we implement SCM. So just walking through this, and then I'll show you a couple examples from my own work in the conservation field. So really, this is pretty similar to other types of quasi-experimental impact evaluation. You need to identify an outcome of interest. You need a really clearly defined treatment. In synthetic control, you have to know the exact start date. But as in any case, you have to be able to distinguish that from other interventions. And you need to define a treatment and a set of potential controls such that the treatment you're looking at only affects your treated unit, doesn't have any spillovers. You need to define a unit of analysis, again, not unique to synthetic control, and often challenging when we're trying to define the counterfactual. You know, for example, if you might use synthetic control to look at the impact of declaring timber concessions, the question is, what's a non-timber concession? Or looking at red projects, as we'll see later, you have to define what's a non-red project. So this can be a little bit challenging. Then with synthetic control, what is a little bit different here is that you definitely need that long time series of both pre and post-treatment outcomes. In addition to what we might usually think of as our matching covariates, the covariates in this case that are structurally related to that outcome. And then you go on to construct your synthetic control, right? So very similar until you get to this point. The synthetic control method is developed by a body, uses a nested optimization approach, which I'll walk through. You can also integrate regression or cross-validation by dividing up your pre-treatment period into a training and a validation period. But sort of the standard approach is this nested optimization, which is what we'll look at. So just to walk through this in equations, here's the setup. So we've got an outcome Y, and that outcome has some counterfactual or non-treated outcome, and then that's shifted by a treatment, which in the case of synthetic control applies to the first unit, because there's just one treated unit at this specific time period, T0. And so after T0, then the difference between these two, the alpha is the causal effect. Right, so that's the basic setup. That baseline outcome is a function of both time factors, unit-specific factors, and some characteristics Z of those units that we're looking at, plus an idiosyncratic transitory shock, epsilon. So just the basic setup. Now we go on to actually estimate the synthetic control. And that synthetic control is going to be a set of weights, which should all be positive and should sum up to 1 across all of our potential comparison units, right? So those are the weights that we're after. Need a little bit more terminology here. So we're going to put together a vector of the characteristics of all of those units. Again, these are the structural factors that drive the outcome, and the pre-treatment levels of the outcome. Often we use like an average across several years of that outcome, but it might be also the annual outcomes. And then we need one more vector of weights, because as we look across this vector Z of different characteristics that might matter to our matching process, we're going to allow the optimization to weight those so we can determine which characteristics are more important and which are less important with this vector V of weights on characteristics. Okay, so the nested optimization process. What we're going to do is look for the set of weights W that minimize the differences, that get the best match between our synthetic control and our treated unit in terms of that set of characteristics X. All right, so we're looking to match both on those structural drivers of the outcome and the historical outcome itself. But remember, we can weight those and give some more importance and some less importance using that vector V. And we're going to choose V such that when we use that set of weighted characteristics to come up with our weighted combination of units, that weighted combination of units is going to follow a trajectory of outcomes Y that matches as closely as possible our treated unit, right? So we're picking weights on the characteristics that we're using to match, and then we're picking weights on the units that we're matching with the end goal of matching on characteristics such that that weighted combination matches our historical trajectory of outcomes. And that's what gives us our counterfactual, right? So that's the weighted combination of the outcomes across time from all of those comparison units. Okay, so done with equations. We go on to telling stories now. So a couple examples of application of this method in the conservation space. And I'm going to walk you through 2 of them, not in any detail, of course, given time constraints. The first is a program in the Brazilian Amazon to build the capacity of municipal governments to help reduce deforestation. And the second is recent work looking at the impact of REDD projects in a sample of countries across the tropics on deforestation and therefore on carbon. And this one is in review. Work led by Thales West. I've listed out all of my co-authors on both of these applications. So first, the Green Municipality Program. So a little bit of background here. As I'm sure many of you know, in the late 2000s, there was a bit of a spike of deforestation in the Amazon, and in response, the federal government in Brazil came up with a new policy to provide a collective incentive to local governments, which are municipalities in the Amazon, to get on board with reducing deforestation. And essentially, this was a process of identifying the municipalities that had the highest levels of deforestation, naming them, putting them on a list, and then targeting more enforcement effort at them, restricting market access, and basically giving them an incentive, a collective incentive, to take steps to reduce that deforestation. So the response of the municipalities, of course, is going to depend on the relative costs and benefits of the penalties that the federal government applies versus the costs and benefits of conservation. And for many of them, the costs of conservation are quite high because they get their tax revenues and in fact, their whole economy driven off of deforestation. But the other thing that matters is the capacity of those local governments to actually do anything about deforestation, right? So they think about costs and benefits, but then there's what sort of personnel do they have? What equipment do they have? What information do they have? So in 2011, the state government of Pará, which is where you see all the green dots in the map here, stepped in and set up a new program called the Green Municipality Program. And they started enrolling municipalities, including preferentially those that had been put on the federal government's blacklist, so-called, to help them better respond to these federal incentives to reduce deforestation. And it was a multifaceted program. It included information, it included equipment, it eventually included some preferential allocation of tax revenues based on that municipality's actions to get its properties enrolled in a land cadastre and to respond to warnings about deforestation hotspots. Okay, so we have this program. The stated goal of the program, what the state government said, was that they were going to reduce deforestation in these municipalities. And so we look at deforestation as an outcome, since that's what they said they wanted to do, measured as forest cover loss as a % of municipal area. But we had actually looked at a municipality that sort of piloted this program early on. And through looking at that municipality, we concluded that there wasn't really a lot of incentive built into the program to reduce deforestation beyond what the federal government was already requiring. So we hypothesized that maybe what the program was really doing was helping municipalities reduce the cost of reducing deforestation, right? By reducing the risks, say, that producers in the municipality would be fined by providing the information and the training that was needed to respond to deforestation and develop alternative agricultural activities. So to measure that, we obtained data on value-added tax receipts to look at a measure of economic activity in these municipalities. We needed to compare the municipalities in the program to other similar municipalities. So in order to do that, we collected characteristics on things that we thought were driving deforestation, so things and driving value added in the economy. So things like protected areas, land reform, land conflict, slaughterhouses. For value added, we also looked at other economic factors. And we looked at these in what's called a donor pool, a set of municipalities that we could potentially compare to these, which we restricted to be the municipalities that were added to the blacklist in the same year. Okay, so we're going to focus on the 18 municipalities in the program that were on the blacklist and compare them to a weighted combination of other municipalities that had been added to the blacklist at the same year, but hadn't had the benefit of this capacity building program to help them respond to the blacklisting. Okay, so here's how we proceeded. So we looked at the deforestation outcome. Here's one municipality called Cumaru do Norte. And what you're looking at here on the left axis is the deforestation in each of these years. The dark black line is deforestation in this municipality. And the light gray lines are deforestation in each of the potential comparison municipalities, which you can see cover quite a wide range. The dotted line is the combination, the synthetic control that is a weighted combination of municipalities that are similar to Cumaru do Norte and that follow a more similar trajectory of deforestation. Up to the black vertical dotted line, which is when Cumaru do Norte joined this program for green municipalities. Right, and so you can see that the synthetic control does in fact match the deforestation in this municipality fairly closely up to the time when they had the treatment, joined this program. And then you can see that deforestation in the synthetic control trends higher than deforestation in Cumaru do Norte, suggesting that the program may have helped Cumaru do Norte bring down deforestation. Okay, so this is just one example out of all of the 18 municipalities that were put in the program. I pulled this one out because it is the only one where we see this potential impact on deforestation. So in all other cases, we don't see any significant impact on deforestation. So one conclusion from this is it looks like the method worked reasonably well. And what we find is this program didn't have an impact on deforestation. We just by chance find it in one municipality. But it's also worth noting that this particular municipality is quite large. And so it faced greater challenges in responding to the federal program because the federal program asked municipalities to reduce deforestation to no more than 40 square kilometers per year, regardless of the size of the municipality. Cumaru do Norte is 17,000 square kilometers, and so it faced some more challenges. So possibly an interpretation here is that really large municipalities actually needed more of that capacity building support from the state government, and it helped them more effectively reduce deforestation. But I also said that we wanted to look at how this impacted the economy of these municipalities. So we also looked at that value added tax receipts, and same layout here. So in gray for all of the potential comparison municipalities that were blacklisted at the same time. In black, the value added in Cumaro do Norte, and in the dotted line, the synthetic control, the comparison that we constructed from those gray lines. Here again, we see that we were able to match the value added up to the point of treatment. And then after treatment, it looks like actually value added trends a little bit higher in the synthetic control, but we find this is not significantly different. So no impact on value added in this case, in this particular municipality. But again, this is one of a large set of municipalities. So here's the whole list of municipalities, and here's a summary of their impacts, the impacts of the program on the value added. So what we find is, so we look here at the mean square prediction error, which is one measure of how good a job we did at constructing that synthetic control. We also looked at how well our synthetic control matched the outcome in the years immediately before treatment. And we looked at how closely the turning points corresponded in sort of the trajectory of that value added, and concluded in the column where it says good quality SCM, whether or not we believed that that synthetic control was a good measure of the counterfactual. So we believed it in Cumaro do Norte, found that the effect was negative. It looked like the program reduced value added, but it wasn't significant. Once we looked at the placebo effects and compared the signal we were seeing here to the noise from those placebo effects, nothing significant. But if we look across all of the municipalities in the program, we find that in general, when we were able to construct a synthetic control that did a good job of matching the treated municipality, in general, we tended to find a positive effect on value added. And in many cases, that was significant. Okay, so our take-home message here is high heterogeneity, and very little impact on deforestation. But in general, we see a trend towards engaging in this program, actually helping these municipalities maintain and increase value added economic activity relative to other municipalities that were on the blacklist. Okay, so a little bit of a messy conclusion. As I said, my conclusions and my graphs are never quite as clean as the bodies. Let me show you one other example here. Just doing a time check. Okay, so second example of applying the synthetic control method in the conservation space. This is work with Thales West and co-authors looking at RED projects. So in this case, we're looking at these individual site-specific projects to reduce emissions from deforestation and degradation. That's what RED stands for. And looking at them across the 6 different countries listed here across the bottom. And you can see that some of these projects had disconnected areas, which we looked at separately. We ended up with 26 of them where we felt like we could construct good counterfactuals for the deforestation outcome in those RED sites. So the question here is, does RED effectively reduce deforestation in these project areas? The background to this one, we'd also done some previous work in Brazil. And you may have seen this paper in PNAS, where we did a similar sort of thing, looking at RED projects just in the Brazilian Amazon. And so for a little bit of context, what I wanted to show you here in this figure is that this is the total deforestation in the Brazilian Amazon across years from 2000 to 2019. So you can see very high levels of deforestation in the early 2000s. The federal government started to bring deforestation down. There was a little bump up I mentioned that motivated the blacklist, came down further, and most recently has been going up again. So in this context, there were these individual RED projects that were put in place in the Amazon to generate carbon offset credits in the years of 2008 to 2014. Those projects were put in place when deforestation was already falling in the Brazilian Amazon, due largely to federal government efforts. But each project, when it went in, had to say how it was going to reduce carbon emissions and how it was going to judge how much it had reduced carbon emissions. They had to establish a baseline. And typically what these RED projects do is they look at the past 10 years, the historical time period, and say, well, that sets the baseline. And that's how we're going to claim credits. If we reduce deforestation below that crediting baseline, then we say we reduce carbon emissions and we get to generate offset credits and potentially sell those in the voluntary market. So in the Brazilian case, almost all of these projects went in at a time when deforestation was already below that historical baseline. And what we concluded from this earlier analysis is that the projects were overclaiming their impact on carbon because they were comparing to a historical baseline that was much higher and had come down because of government efforts. But they couldn't really claim credit for that, nor could they be blamed for the recent uptick in deforestation, which are all related to larger trends in the Brazilian Amazon. Okay, so if you've seen this paper, you might have wondered, because we wondered, is this unique to this setting in the Brazilian Amazon where deforestation was brought down by the federal government? These projects were created. They used historical baselines that happened to have those higher levels of deforestation from earlier years. And that led to this situation where we found, as we say in the title here, that the projects were overstating their effect on reducing carbon emissions because they were using this historical baseline. So to assess whether there might be more general problems with the reductions in carbon emissions claimed by RED projects, we looked across other countries and we picked countries that had a substantial number of RED projects and that cover a range of conditions in all of the continents in the global south. So across these 6 countries, and these graphs are similar to the one we just looked at. So for each country, this uses the Hansen data to look at total deforestation across years in these countries. And the blue highlighted bars are the years in which RED projects were instituted to generate carbon offset credits. So there's not much of a pattern here. We don't see the same pattern as in the Brazilian Amazon. So this, I think, provides a good test when we're looking at what these carbon projects are claiming. It's not that in every case they happen to start when deforestation had been coming down, right? This varies quite a bit in terms of what had happened before the project started and what was happening after the project started in each of these regions. Okay, so one challenge that we faced in this project is we had to identify a set of comparison units. And this goes back to what I said before. It's a challenge we face across all quasi-experimental impact evaluation, is defining what are the units that don't have the treatment. So in red here in the DRC, this shows an example of a RED project, which was put in place in this particular location. So the question is, what's a non-RED project on the landscape, right? And what we did, or what Thales did, to give credit where credit is due, is generated potential control areas that had the same area as that project area, the same land area, but basically were spherical control areas, generated 1,000 per project, to have comparison areas that could have been RED projects, but weren't. And then we figured out the characteristics of those areas and applied the synthetic control method to generate combinations of them that tracked deforestation in the RED project. Okay, so the results across all of the projects we looked at and all of those studies. So what this is showing you in red is the deforestation in the RED project area, right? And then in blue, those are the RED project. And then in blue are the placebo effects. So what we found when we ran the exact same procedure, just as a body recommends, for all of those spheres that I just showed you, to see how much noise there is resulting from this method. Like, what are the hypothesized or the hypothetical effects of placebo interventions that didn't actually occur in all of those spheres. And so as you look across here, you see that in a number of cases, the RED project does appear to have reduced deforestation, but there's no, in other cases, appears to have increased deforestation. And in many cases, the red line is tracking along in the middle of the blue dots, right? And the blue dots are all of those placebo effects. The blue shaded area is the confidence interval, the 95% confidence interval around what should be a zero placebo effect. Okay, so this is a lot to take in, but I'll tell you in general, we find that lots of the estimated impacts of the red projects fall within the noise that we find from all the placebo effects. So one exception to this is in Peru. So let me draw your attention to the bottom left quadrant here. So these are all the projects we looked at in Peru. And you do see that about half of these, the estimated effect of the red project in terms of reducing deforestation, that's what's shown in red, falls below all of the noise that we estimated from those placebo tests, right? So the significant effects in about half of these projects in Peru. But if you pull back and look at the picture in general, it doesn't look very good for red projects, right? In general, these red projects are claiming that they're effectively offsetting emissions. But if we use the synthetic control method to look at what actually happened in these project areas, we don't generally find an effect. Okay, so those are my two illustrations in the conservation field. I think I've got a few more minutes. Paul, can you give me a time check?
I believe I have to do the math. Yeah, you're about 30 minutes. Joanna, am I correct? Maybe a few more minutes?
Yep. Okay, so can I steal a few more minutes?
Yeah.
Paul and I work together long enough that he knows I tend to run long, but I'll try to be quick here. So just summarizing, so why are we using synthetic control in those cases, and why would you want to use it? When there's a single treated unit like California, or just a few units where we expect the impacts to be heterogeneous, like with the Green Municipality Program or RED. When the treatment or the outcome is defined at the aggregate unit level, when you that's what you're treating. You're treating a whole municipality, and maybe you only have data on the outcome at the municipal level, like value added. We only have that measured at the municipal level. Another point is that if you're interested in spillovers and leakages that occur within that unit, you can capture those in synthetic control. So often when we're doing impact evaluation, we think of the spillovers and leakages as nuisances, things we want to avoid. But if you're actually interested in the conservation intervention, spillovers sort of enhance your impact and are things you might want to promote. So it's useful to be able to capture those at least within the aggregate unit you're looking at. Fourth, if you're interested in the evolution of the outcome over time, not just a single time slice. And then last, if you don't really believe an assumption about selection on observables, you don't think you can observe everything that lets you get good matches, synthetic control lets you also look at that time trend of the outcome and effectively capture some of the unobservables in your matching process. A couple things that are really different about SCM. In the first step, when you're constructing the synthetic control, it's worth noting that you're matching based on the structural determinants of the outcome, the lagged values of the outcome. So this is different than traditional matching, where you're typically focusing on matching covariates that explain the treatment, right? And this means that each time you do synthetic control, you're building it around the outcome that you're interested in, and you need time series data on that outcome. And then as I quickly illustrated, you don't have traditional statistical testing here. You're using permutation tests, whether it's placebo tests. We've used bootstrapped donor pools. Some have recommended pulling out different covariates and looking at sensitivity to the set of covariates you use and weight. Okay, some other applications. I wanted to throw these up and encourage anyone in the audience to put into the chat, maybe others that I've missed. There's lots of interesting work going on here. So this first working paper looks at not only impacts on deforestation, but land use and trade flows. We've looked at impacts of certification. The Roopson paper looks at this at the national level. So again, let's see if we can maybe crowdsource together other interesting applications of the synthetic control method. Last two slides, Paul, I promise. Just wanted to mention that there's some applications in adjacent fields. So ecology has picked up this method to look at the impacts of large manipulations, like of entire ecosystems or large scale fires, and looking at this to look at the ecological impacts. Pushpender Rana and Dan Miller have used this method to in their exploration of what are the key drivers of the long-term outcome trajectories. So which structural factors do matter most in explaining those outcome trajectories. And last, and I think really interesting, VERA or VCS, which certifies lots of RED projects and has to figure out a way to set up these crediting baselines, has recently adopted a new approach, or is allowing project developers to follow a new approach, which they call dynamic performance benchmarks. And dynamic benchmarks really means what we consider impact evaluation, right? So identifying a set of comparison plots or comparison units and tracking the outcome in those units. And part of the discussion about potential ways to do this has included using synthetic control methods to identify good comparison units for RED projects, and then using those comparison units to evaluate how many carbon offsets are being generated. There's also lots of methodological development in this area. So I think you'll have this in the recordings. Here's some citations for generalized synthetic controls, augmented synthetic controls, matrix completion methods. So an area of really rapid methodological development. And just as a last slide here, just wanted to throw out a few more ideas. I think there's a lot of potential to use synthetic control methods integrated into our study design. For example, as a way to identify potentially good control units where you might then want to go in and do surveys. So thinking about this not as the method that we use for the sole method we use for the impact evaluation, but integrated into our methods. I think there's a lot of potential to look at more distributional outcomes, Gini index, sort of other types of landscape measures that look at what's happening within our aggregated units. And finally, I wanted to reference back to Johan's talk last week, where he talked about the potential that we'll see new remote sensing measures of poverty or of socioeconomic status that would be higher frequency and wall-to-wall, and make it more possible to use these types of methods to look at poverty outcomes as well. So I'll stop there. Thank you.
Thank you so much, Erin. So at this stage, I will open the Q&A so that we make the most out of the time we have left. And I've got a long list of really good questions. And I think I would like to start a little bit provocatively. So since this method actually has been around for over a decade and even longer, if you actually consider that the first versions were published as early as 2003, why do you think that there are so few applications still at this point in conservation? So is there something that in the conservation sector make it extra challenging? I'm thinking more about kind of spatial figuration, spatial spillovers and things like that.
So I think really it reflects more recent recognition that there's this huge opportunity and increasing opportunities. Again, I'm going to reference back to Johan's talk last week and talking about what all the new remote sensing sensors are giving us in terms of new long-term data sets that we can look at using these methods, right? And I think that's really where one of the biggest opportunities is in conservation. And we didn't previously have such long-term high quality data on the outcomes we were interested in, right? But now that we have this remote sensing, we will be building that going into the future, right? And again, we need it both pre-treatment and post-treatment. So just because you've got your perfect satellite now, you can't necessarily apply synthetic control until you've got a long enough pre-treatment period of satellite measures. So that's my hypothesis about why we're seeing it now, that it tracks along with the availability of the data.
Right. And I will continue a little bit on the same theme. So we got a few different questions actually very much related to the type of treatment that would go into synthetic control methods. So what if the treatment is continuous? Does this method only actually apply to dichotomous variables?
So I have only seen this method applied to dichotomous variables or categorical variables, right? I think you could imagine different comparisons. So again, thinking back to earlier talks in this series, there is some discussion about evaluating the impacts of different types of protected areas. So that would be a nice case for this, right, where you might compare within the total pool of protected areas, what's the effect of having stricter protection, right? And then you might define stricter protection versus less stricter protection and compare across protected areas, right? So that's looking at a treatment that has different levels, but doing it by turning it into a dichotomous question that you could then apply synthetic control to.
Right. And then there are a few questions, or actually quite a lot of questions related to the kind of the quality and how you assess that. You touched upon it a little bit, but could you elaborate a little bit more on that? Let
The
me
quality
see if
of
I find
synthetic control?
Exactly, yeah. So like, how can we actually know whether it reflects kind of plausible counterfactual scenario, and how credible are the results in light of that? Could it just be a failure of the method, I guess is the question.
So I think the starting point is to see whether it's accomplished what you set out to accomplish, and you set out to accomplish in the nested optimization, sort of minimization of the prediction errors, right? And so the one key summary measure is to that mean square prediction error, and to look at that. In addition, people generally look at the trends and just visually, does it look like the turning points match? I think it's particularly important to look at the match in the years just before treatment. And in fact, in some cases where we found systematically bad matches right before treatment, we have differenced out those remaining differences in the few years just before treatment. They can show one more approach here, which Thales applied in this recent work that I mentioned, and that is we divided the pre-treatment period into two intervals, a training interval and a testing interval. We constructed synthetic controls using only data from that training interval, and then we checked how closely they matched in the testing interval. And for that particular paper, we only kept synthetic controls, or we only kept cases where we could get synthetic controls that had an error of less than 0.5% of the area of that project, right? So this is another way to think about testing whether your synthetic controls are really good enough. So again, another active area of research. I don't think there's any one test for this. I think it's important to think about it from multiple perspectives and using multiple tests.
Great, thank you. And then there's some questions related to you started by mentioning that this is particularly suited as a method for unanticipated treatments or policies that are coming up. But then on the other hand, there were other questions then later on building back on the fact that what if actually the units that you have been using to build the synthetic control later on would be also become treated due to similar unanticipated policy processes? Is there somehow using these methods a way of taking this into account in the analysis?
Yeah, so that's a fantastic question. And that's, I think, a really challenging aspect of using these methods, both the way we use them for sort of ex post impact evaluation and, for example, for the way VCS or Vera would like to use them to build up a whole system for evaluating the impacts of their projects. So if you have a unit in, first of all, you would start, if you were doing ex post analysis, with only units in your control pool that hadn't had a similar intervention. Okay, so going back to Abadi's case, I think he only used 38 states to compare to California because he determined that the others had had interventions that were too similar to Prop 99. Okay, so that just begs the question of what's too similar, right? But somehow you figure out and you decide that you're looking at the impact of a treatment that you can define as distinct from anything else that occurred in your donor pool, right? So it's almost something you define internally to the process. If you had set up controls and they were then going to go forward looking at impacts as they occurred, I think the right approach would be to have a standard for deciding what was a policy that was too similar and then taking that unit out of your synthetic control if it occurred. But I do want to say there's another way to think about this, right? So it could be that one thing that attenuates or dampens your impact of a treatment is that if your treatment doesn't apply to a unit, maybe other interventions are more likely to occur in that unit, right? So you might have sort of other compensating actions. And so I think we need to think carefully about how to define whether another intervention is the same as the one we're looking at, or is that other intervention possibly something that we might expect to happen in our control units in the counterfactual case, right? And therefore we do want to include that in our counterfactual and recognize that that just reduces the total impact of our intervention, because not having the intervention might encourage other interventions. So it's not really an issue specific to SCM, I don't think. I think it's a general issue for impact evaluation.
Yeah, I 100% agree with that. And I think, unfortunately, we have time for one final question, which is about the fact that synthetic control methods most often have been applied ex post, so after an intervention has been assigned. Have you come across any examples where it would have been applied ex ante, so that actually somebody would start to anticipate an intervention coming up, such as, for example, already at the planning stages of establishing a protected area or a red mechanism or something, and then after implementing the intervention, SCM would then be used to monitor the outcomes?
So there's definitely been discussion of that. I can't point you to any specific examples, but when we were looking at the Green Municipality Program, that was definitely one interest of the donors, was whether we could set up, identify our synthetic control in advance, and then they could use that to track impacts over time. I think the only reason that didn't happen is political changes and funding changes, reduced interest in tracking impact and changed the nature of that program. So I think potentially it would have been possible to do. That's also very much what the people who develop methodologies for VCS are thinking about, whether using synthetic control matching or sort of traditional nearest neighbor matching. Can they identify controls in advance before they know the outcomes, and therefore reduce any possibility of cherry picking controls, right? And use that as a legitimate way to track the impacts of those RED projects or other types of forest carbon offset projects. So again, an active area of research. I think there are probably lots of opportunities for collaboration and thinking about how to transfer these methods from our space of ex post impact evaluation to the world of setting up systems for evaluating impact of interventions as we move into the future.
Thank you, and I think that's a great way to end. So lots of scope for future developments in this sphere. I think definitely I have the same feeling. So let's just thank Erin for a great talk and a great way of answering our questions.
Thanks, everyone.
And then I would like to give the floor actually to Seb Kostadot, who is a board member on the Impact Evaluation Working Group, and he has been setting up a marvelous mentoring program that we are going to launch today, and more information will follow also on the email list. So let me just share my screen and then I will give over to Seb.
Thank you, Joanna. So so thank you everybody. Once again, it has been a very great, a lot of people have joined, so we are very excited about that. And at the board of the Impact Evaluation Working Group, we're thinking like maybe we can do more to help the community. So we are launching the first edition of this Impact Evaluation Mentoring Program. That's targeting people who have started that, let's say, that learning journey on impact evaluation. Not necessarily researcher or students, it can be project manager or conservation practitioner, because these methods are increasingly applied in many settings. But if you're already on, designing an impact evaluation, starting an analysis, let's say you have learned the very basic, but you are still, it's still an uncertain path, or it's a very complicated journey. I think this mentoring program can help you to be connected with someone with more experiences, and then you can ask all the questions you don't want to ask your co-author or your collaborators. That's this program can provide provide some support. Of course, if you need very specific if you have specific and technical needs, it's better to reach out directly to expert and researcher. The mentoring program it's a work at the more broader level to support, let's say, early user. I mean, people who are just starting knowing and applying these techniques. So feel free to apply. I've put the link on the chat. Try to apply this month so we can start forming pairs of learning mentees and mentors. And as well, I have seen a lot of names attending today that are probably folks that are more experimented. So I encourage them as well to apply as the mentor and devote a little portion of the time. It will not be a burden, but helping like our junior colleagues navigating this wonderful journey of impact evaluation and exploring a lot of opportunities, trying to learn specific skills, understanding what are the career opportunities, and all of this. So please read the description of the program, apply, reach out if you have any question, and we hope to select to select a number of a number of applications to start a program. That will be the first edition, and then we hope there will be much more. But yeah, check the rules before applying. Here are the link. We will send an email, and on Twitter we will be very actively promoting the program. And I hope you will be as excited as we are about this new opportunity.
Great. Thank you so much, Seb, for that introduction. And as said, more to follow. And now I seem to have let's see now if I can, my slides are stuck. No, there we go. Sorry about that. So I think it has become time for us to thank you for attending today. And before we close, I just wanted to flag Sabrina Eisenbart's talk in a month. So Sabrina will be with us, and she will be speaking about harmonized implementation experiments in conservation. And please note, it will be again the same day, and the aim is to have it the same time. So the Tuesday, the 1st of November. And again at 10 a.m. Eastern time in America, but because Europe actually changes from daylight saving time 1 week ahead of the US, this will actually exceptionally mean that in Europe we will start at 3 p.m. Central European time and not 4 p.m. As so far. So there will be this 1 week when it will be 10 a.m. in the US and 3 p.m. at Central European time. So please note this, but I will again try to send out the reminders over email for all those people who have registered to make sure that we don't get the time wrong. These time changes are always very confusing, and I'm sure I'm not the only one disappointed that EU didn't manage to get rid of this thing. But finally, I would just like to thank Erin once more for such a great talk, really inspiring. I think all of us really now will look more into the possibilities of synthetic control methods for our conservation applications. And then also Paul and Seb for helping to co-host today's session. So thank you on my behalf, and looking forward to see you again in a month.